Right. So 16, 15, 15. Okay. So 15 may, it's very simple. All you need to do is just know the trends of solubility of group 2. Group 2 is another chapter of AS. Okay. So group 2 hydroxides and sulfates. Hydroxides become more soluble and sulfates become less soluble down the group. So if you talk about magnesium and strontium, so magnesium is up here, strontium is down here. So strontium will have a hydroxide that is more soluble, but the sulfate that is less soluble. So when sodium hydroxide is added, strontium hydroxide will not form the precipitate, rather magnesium hydroxide will form the precipitate. So yep, note about this one. So sulfate, it's strontium sulfate that forms the precipitate because sulfates become less soluble going down the graph. So therefore option B is correct. Okay. Now question 16. Volatility of group 17 elements, chlorine, bromine, iodine, decreases down the group. This is because, now just look at the halogens, chlorine, bromine, iodine. Down the group, what's happening? They're all nonpolar, first of all. If they're nonpolar, then the major intermolecular force responsible for the melting point and volatility is the van der Waals forces, or IDID forces, instantaneous dipole and induced dipole. Now, going down the group, what happens? MR is increasing, right? Number of polarizable electrons increase. Therefore, strength of van der Waals forces also increases. So going down the group, what's happening? Bond length. Bond length is not responsible for the volatilities. Cancel it out. Bond strength, which one? Don't know. Electronegativity also not responsible. Yes, it's the number of electrons because it's because of the number of electrons that the IDID forces become even stronger. So question 16 has to be D. Okay. Now question 17. Bromine is extracted from seawater. In the final stage of the process, two redox reactions take place right here. Bromine will first react with sulfur dioxide and water to form HBr and sulfuric acid. HBr further reacts with chlorine to form bromine and HCl. Now, which row is correct? Strongest oxidizing agent out of these. Oxidizing agent की आप बात करें तो वैसे even without this, from your theoretical knowledge, you can answer this. You know that halogens, their oxidizing powers decreases or reduces down the group, right? So chlorine will have the strongest oxidizing power compared to bromine. Sulfur dioxide is a reducing agent, so it will not be a good oxidizing agent anyways. It's either of these two, either B or C. Now, bromine and sulfur dioxide, and weakest oxidizing agent has to be sulfur dioxide because that's a reducing agent. So it's the option B should be the correct answer. Okay, sulfur dioxide is a reducing agent. We know this from the course. Bromine is a weaker oxidizing agent compared to chlorine because it's down in the group, right? It's here. Chlorine is above it. Chlorine is a stronger oxidizing agent. 18. When burnt sulfur forms a gaseous product X, which can be oxidized to produce gas Y. Gas Y reacts with water to produce a product Z, which row correctly shows the oxidation state of X, Y, and Z. Now, this is a very important. Now, you have sulfur. Sulfur can form a gaseous product X that can be oxidized to form a gas Y. What comes in your mind by looking at this particular scenario? So, sulfur first gives you a gas. We studied about sulfur dioxide, and it can further be oxidized to sulfur trioxide as well. Sulfur dioxide might be X, sulfur trioxide might be Y. Reacts with water, meaning sulfur trioxide can dissolve in water and can form sulfuric acid as well, right? H2SO4. Although this reaction is not allowed under lab conditions because this is highly exothermic. Which row correctly shows the oxidation states of sulfur in all three states? In this case, it's +4, right? Because it's in this case it's +6 because of the oxygen, and in this case it's gonna uh, stay +6. So option D, +4 +6 +6. You can just do the calculations here now. Okay, option D is correct. 19. One molecule ammonia reacts with one molecule of ethyl methanoate to produce one molecule of methane amide and only one other molecule X. Now, one molecule of methane amide decomposes on strong heating They produce one molecule of ammonia and only one molecule of Y. What could be the identities? Actually, now in this particular question, they've done a lot of molecule in the air to confuse you. This is very simple. Have ammonia has to react with ethyl methanoate. So let's just draw it here. This is an ester है ये, ठीक है? And this will form methylamide. So there you go. This is your methylamide. Now, along with something else. Now that something else is what we need to guess. So how would methylamide form? So you can just break it from here. This side will form the acid and this side will form the alcohol. And this has to be an alcohol because that's how esters are made. The acid reacts with ammonia. Alcohols don't react with ammonia. So C2H5 along with the OH, right? This is an alcohol. At this part is a carboxylic acid. So this is your alcohol. So this X has to be ethanol. You see the C or D. What about Y? Now, one molecule of ethanamide decomposes on strong heating to produce one molecule of ammonia and something else. Now, this is on strong heating will give you ammonia along with something else. So, along with this something else, this can either be hydrogen cyanide or carbon monoxide. So, what do you think it might be? Just by looking at the formula, we can actually guess an identity for it. If NH2 and hydrogen have gone to form ammonia, then CO is left and it might form carbon monoxide. So C seems to be a reasonable answer. And yep, C is the answer. Okay, that's how you are gonna infer your answer from these structures. Although the structure is not a part of the syllabus, still you need to guess the answer out. Now, which type of stereoisomerisms are shown by 2,4-dimethyl hextuene? Now, just look at this name. This name contains an alkene in it. So if it's an alkene, let's see how it would look like. Now it's hex. If it's hex, so it has to be 6 carbons. 1, 2, 3, 4, 5, 6. Now it's 2-ene. So it's after the second carbon, you have the double bond. Now then you have 2,4-dimethyl. Okay, the second and a fourth. So second and then the fourth. We got two methyl groups. Yeah. Whichever stereoisomerisms are shown. So it's either cis trans or optical. Now let's see. Just by looking at it, well, this double bond cannot show cis trans because if you look at it, both the groups are exactly identical attached to the same double bonded carbon atom. These two groups have to be different if you need to show cis trans, so it cannot have cis trans. What about optical? Well, for optical, all four groups have to be different. Let's look at them. We've got a hydrogen, you've got this entire group, you've got a methyl group, you've got this entire group. All four groups are different, so this has to be chiral carbon or chiral center. Therefore, it will only show optical isomerism. So optical isomerism only. Okay, that's it for this video. And I'll continue in the next video.